We're getting close, and we are recording. Okay. Welcome, everybody. We have 44 people so far. I'm sure we'll have a few more. Welcome to the October 2020 monthly meeting, once again online. Can you all see my screen?
Your voice is fading.
My voice is?
That's good.
No, you're loud and clear.
Okay, and you can see the screen?
All I see is a Mars candy bar.
That's it. Yeah.
Okay.
It's the opposition of Mars. It's going to be a really sweet sight. You'll see. Okay.
I do not oppose that type of Mars.
All right. So with the board currently is myself on the top left there, Dave Faulkner, and then we have Baltz in the middle who's vice president. We have Matt, who's treasurer, at the top right, Trina, in the bottom left, and then we have Gunnar, who's a board member at large, and we have Conrad, who is a board member at large. Trina's the treasurer. Trina is the secretary. Matt's the treasurer. Okay. All right. Let's see what we got here.
It's been a long day for you, hasn't it, Dave?
Yeah, it's been a long day for me. I wanted to bring up the tragic death of our good friend Joe Timmerman, who passed away earlier this month from a bicycling accident. He was on an off-road trail with his wife, and they were riding a trail he's probably taken before. I don't think this was the first time on it, but he took a spill, went over the handlebars, and died at the scene. Very tragic. He was a great guy, fun to be with, always very, very happy. He had a nice place out in Hayward, Wisconsin, had a observatory that he built out there, but he's one with the stars now, so we're sorry to see him go. Okay, a treasurer's report. Matt, do you want to go ahead and do that, and I'll admit people? Matt, are you there?
It looked like he disappeared off the meeting.
Yeah, that treasurer has left the group. That was about a minute ago.
Oh, great. So he's taking the money and run, apparently. So we have total cash on hand of $169,565 and change. Got 166 in the bank. Mostly money that's been accumulating towards the own and roof repair, which will be starting shortly after the Mars opposition. We also transferred in $12,000 from PayPal. That accumulates, and we transfer in the money every so often. For expenses, $45.59 was the normal operating expenses, and we had a $3,500 final bill to the VAA engineering firm for the own and roof plans. There you see the PayPal, which is almost all of it is the income from membership and donations. Vanguard, we don't have any balance in that right now. And the upcoming major expenses for 2020, of course, we know about the dome repair from JJC. They still haven't gotten a final invoice on that. So we believe we owe $93.75 on that. And then the ELO roll-off roof, which I mentioned before. And we have a $59,000 and change balance on that. And as of October 1st, we have 527 members, which is good. We're still maintaining on that. So good deal. Any questions?
When's the roof repair going to start, Dave?
When does the roof start? It will be shortly after the Mars opposition. So after the Mars opposition, we'll schedule a work party to go in and take down the telescopes and mounts, and then they may do some work outside of the observatory prior to that, but it won't interfere with the start party. So
yeah, I think Merle has a post on the forum about help needed to take down the telescopes on the October 11th, because they're going to be doing stuff with the roll-off on the 12th.
Okay.
Thanks, guys. Looks like Matt's back.
He is. Okay. Matt, I went through the treasurer's report. Do you have anything else to add?
No, I think you covered it.
Okay, you're really soft.
Your volume's down.
Yeah,
I'll work on it.
Okay, sounds good. All right, and then we have the chat open too. I should open that too so I can see what people are saying. So we're logging into another email account. Okay. All right. Loaner Scope program. Anton, are you on?
I am here.
Would you like to talk a little bit about that?
Yes, the loan scope program is still going strong. We've had 57 loans now this year. Of course, members can request telescopes by going to our website under members, loaner scopes. All of our telescopes are either out or awaiting pickup here in my garage. And all of them are also have waiting lists. The only one immediately available is the solar scope. And so while I just pointed out that members can certainly request telescopes this year, given that they're booked into November now already, I don't know that I'd be able to fill all requests coming in. Just a heads up. And so that's it.
All right. Yeah, that's good to know. How are the courses doing?
There's been some demand for those. Those will be available. There are a couple of them out. I've got some of them in. So I don't know. There's been half a dozen, 8 or so, maybe that have gone out this year. But
Okay.
yeah.
Very good.
Hey, Anton, so
Yeah.
there was some talk recently about adding some more loaner scopes. Has there been any movement on that?
A little bit. I have one more Celestron SCT down in my in the garage right now that I just about have ready to go out on loans, but I don't really want to put that one up on the website this year because the other Celestron SCT is really booked. So I'll use that one to take up some of the load on the one we have. So even though it's not even available yet, it's already booked.
Yeah. All right. Very good. No, that sounds like a plan. Okay. Upcoming celestial events. So we have a full moon tonight. We also have Mercury at greatest eastern elongation, 25.8 degrees. Venus tomorrow will be just 0.1 degrees south of Regulus. So that'd be pretty nice little conjunction there to see. On October 3rd, there's a Mars-Moon conjunction and an occultation, but not here. The occultation is way in southern South America. So October 10th, you have the last quarter moon. As we all know, October 12th is the opposition of Mars. October 21st, the Orionid meteor shower peak. And then the outlook for that is considered to be pretty good with a zenith hourly rate of about 25. Don't think it's a really bright meteor shower, but if you happen to be in a dark location, it might be a good sight to see. First quarter moon on October 23rd and October 31st, you have another full moon, which should be considered a blue moon by some accounts. And then Uranus is also at opposition on October 31st. I really don't have much more about Mars at opposition. Merle, are you on? Okay.
I would add something.
Well, I actually, we have a whole presentation on Mars at opposition.
Yep.
But what I'm saying is that Eagle Lake Observatory, I think that we have a couple of star parties, and I want to know if Merle wanted to talk a little bit about that.
Yep. Can you hear me?
Yeah, now.
Oh, what you need to know? We have a public star party.
Do you need more people?
Okay, public star party on October 9th and October 10th for the Mars opposition. Reservation only, and all reservations are full. But all the key holders can come on out and help. That would be nice. If we had actually additional telescopes to set up on the plaza, that would be nice. It would just give more people, or give the people more places to observe. So again, not only do we have Mars, we got Jupiter and Saturn that are fantastic right now too. So
Okay.
Okay.
Very good. All right. Anything else about upcoming celestial events? Okay, so what do I have next on here? The October Star Parties. Okay, so I guess that kind of was a good segue into that. We have the impromptu Star Parties by site. See the forums. That seems to be working pretty well. And I see impromptu Star Parties all the time up there, so I'm really happy that the sites are being used and that people are getting out and observing. Public Star Parties, as Merle mentioned, we have the Friday and Saturday, October 9th and 10th at Mars Opposition Star Parties. And then we have another one on October 24th as well.
Oh, Dave?
Yeah.
Anything after October 10th is being canceled
It is. Okay.
because we're taking the scopes down and owning.
Okay. So we'll have to post that. October 24th is canceled if you haven't done that already. Are you doing that? I guess all of them, because it gets into November, but we don't know how long that's going to last.
I put a note up on the homepage.
Okay. All right.
Events are canceled, but we're hoping for the super conjunction in December.
In December. Right. Right. Okay. Good point. All right. Thank you for that. And then the MAS Mini Messier Marathon, also known as the 4M, is going to be canceled as well. I talked to Jerry and to Chris, and they don't feel that we're in a position to hold that this year. So,
hey David, it's Suresh. We're going to schedule the next beginner session, the next BSIG for October 24th at the Metcalf.
Yes, you are.
There it is. Thank
How
you for
about that?
That's
Yeah, slid aside in there for you, buddy.
That's awesome. It's not entirely accurate, but it's good. Yeah, October 24th, the Saturday is the primary day, but it's actually the Friday, the 23rd, that would be the backup.
Oh, okay. I thought it was 24th, 25th. Okay. Well, anyway, that weekend, right? So Friday if it's clear, Saturday.
Saturday if it's clear, because it's easier. This time of year, we have to get there earlier.
Okay.
We have to get there at 5 or so because it gets dark early after 6. So Saturday's the primary, with Friday being the backup. And I'll make the call on Thursday.
All right.
But as you say, see the forum for more details.
Sure, absolutely. Yeah.
We had really good turnout, and really good. It was really good energy at the last one a weekend or two ago.
Yeah.
I'll say we had about 25. I didn't do an official count, but there's about 25 people out there. And even though it was mostly cloudy, we had a lot of fun. So people that came can attest to that.
Okay.
So the rest of you come to the next one.
There you go.
Since we're on the same topic, just to let you know, we did get a couple of speakers in for the fall and winter. So on December 12th, and I'll put this on the forum as well, but on December 12th, Bob Kerr is going to do a talk on, it's got an interesting title. It's Arcturus, Betelgeuse, Capella, etc., the ABCs of stars.
Okay.
And then in January, I believe it's the 19th, I'll have to confirm that, Mike Shaw is going to return to do another landscaped imaging discussion. And as people that know, Mike Shaw is like phenomenal at astrophotography, especially with landscape involved. So in the past, when he's come, we've packed the room because everybody loves doing this. Anybody has a camera can do it.
Right.
So we're going to do that again in January.
Okay.
And then in February, somebody mentioned that they were willing to do a talk. I can't remember who it was. Oh, it was Dave.
Yeah. Yeah.
So
Probably going to talk about the mythology of the night sky. I have a new book that is coming out. It's actually a second edition of my book. It's now available in the ebook form, and the hardcover will be out shortly. So that's the second edition of Mythology of the Night Sky. So, all right.
For the fall and winter.
So, Suresh, while you're on, let's talk about Mars. Okay. I'm going to go ahead and back out of this and let you go ahead and share your screen.
All right. Hopefully I don't mess this up. Can you guys see me now?
Coming up. Yep. Got it.
All right. Here we go. Where's that little slide button? All right. So everybody, as you all know, Mars is coming to opposition this month. It'll be the best Mars apparition up until 2035. So if you want to see Mars well, this would be the time. As Dave mentioned, Mars comes to opposition, I believe it's the evening of October 12th, 13th, but Mars is actually closest to Earth on the 6th. It's a little quirk in its orbit explains why that is, and I'll talk about that in just a second. This picture, by the way, was a Hubble image from earlier this year, I think a month or two ago. So I thought it was pretty cool. You got Syrtis Major here. It's upside down, so this is South Polar Cap, Syrtis Major. Anyways, pretty cool image. And if you guys are on Facebook or another social media platform, there are a lot of phenomenal amateur images out there now. The ability to take pictures of Mars through your telescope is got so much easier, and so anybody can do it. We have people in the club that do it. So if you're interested, see me or some of the other people that do that, and we can try to help you get started. Anyhow, here we go. Why is it a special year for Mars? Mars passes close to Earth every 26 months. So why is this any different? The reason is because not all Mars oppositions are the same. This little graph here on the upper left, excuse me, is it accentuates the orbits of the planets. So here's the Earth in its orbit, and here's Mars in its orbit. And if you notice, Earth's orbit is pretty circular. I think the closest we're 91 million miles from the sun, and during aphelion or the furthest, we're about 94 million miles from the sun. Mars has a far less circular orbit. As you can see on this side, it's actually much closer to the sun than it is on this side, as you can see. So not having a circular orbit really makes the apparitions with the Earth different every time. So close passes between the Earth and Mars happen roughly every 15 years. And that's when Mars is approximately here, its closest approach to the sun, and the Earth happens to be in the same part of its orbit. Typically the closest that we pass to Mars when it's closest to the sun is in early August, right around August 3rd or so. And indeed this year, Mars did pass closest to Earth or to the sun on August 3rd. So now it's starting to move away again from the sun, so it's going out like this. And that explains why it's actually closer to us on the 6th than it is when it's at opposition, i.e. lined up with the Earth and the sun on the 12th, 13th. It's actually a little bit closer a week before because Mars is actually going away from us from the sun as we speak. So during the closest oppositions between the Earth and Mars, which would be simulated down here, it's about 34.6 million miles apart. But when we have apparitions and oppositions out on this side, Mars can be as far as 63.1 million miles away. So you can see Mars' orbit is really uncircular or not circular. Furthermore, since Mars is a small planet, it's half the size of the Earth, or a little over 4,200 miles in diameter. When it's furthest away from us, it is really tiny. It's about 4 arc seconds when it's at superior conjunction or opposite the sun from our vantage point. When it's closest to us, it can be as much as 25 or 25.1 arc seconds. So more than 6 times bigger when it's close than when it's far. Compare that with a planet like Jupiter or Saturn. The difference between when it's at opposition to when it's at superior conjunction is not that big, at least as a percentage, on a percentage basis. And for Uranus and Neptune, it's hardly negligible. But for Mars, it makes a big, big difference. And also, another reason why this is a special year is for those people that looked, the last time it was close in 2018, it was actually closer to us then, but it was very low in the sky because Mars, like the other planets, it follows the ecliptic of the plane of the solar system. And sometimes Mars is low and sometimes Mars is high. This time, Mars is much, much higher than it was 2 years ago. It's about 30 degrees higher in our sky, which makes all the difference when you're looking for very minute surface detail and the like. The reason is because when it's high, we're looking through less atmosphere. When an object is at the horizon, we're looking through about 25 miles of atmosphere. When it's straight up, we're looking through about 6 miles of atmosphere. So that makes a big difference in terms of the steadiness of the image, the clarity, the transparency, and the like. On October 6th, which again is closest approach, Mars will be 38.6 million miles away. So this is the closest it'll be until 2035. At that time, it'll be 22.6 arc seconds across. People that have looked out there now can see it's a brilliant beacon, orange beacon out there after dark. It's at magnitude minus 2.6, so it's already brighter than Jupiter now, and it's going to get slightly brighter as it gets closer to its brightest next week. On the 6th, it'll rise just after sunset, and it'll pass due south at 1:44 a.m., and it'll set about 8:10 a.m. And as Dave mentioned, opposition is the following week, October 13th. So this chart up here in the upper right kind of explains the past few apparitions of Mars, the next 3. You'll notice the size difference, and this pertains to this orbital difference that I talked about earlier. So in July of 2018, Mars was actually bigger then than it is now, but it was much further south. And of course, we had the big dust storms on Mars back then, so you couldn't see any surface detail whatsoever. This time, even though it's not quite as big, 22.4 versus 24.2, it's much higher in the sky, and knock on wood, there hasn't been any dust storms to blot out anything on the surface. As mentioned, Mars is probably the planet most affected by distance. These are some images taken coming up to this apparition. It approximates backwards and forwards the size difference. So on July 15th, which was what, 3 months ago, basically 2.5 months ago, Mars was about a little over half the size than it will be on the 6th. And you can see the difference in how detail kind of is easier to see when it's bigger, right? So you really have about a 6-week window from, say, September 11th to, I'll say, November 15th, somewhere in here is really the window. Maybe it's 2 months instead of 6 weeks. But on September 15th, Mars was already 21 arc seconds. And on October 15th, it'll be down to 17 arc seconds. So we really are in the window now to see the great detail on Mars. Whenever Mars exceeds 20 arc minutes in size, or arc seconds in size, I should say, that's considered a great apparition. And so right now, Mars is a little over 22. I think it's 22.2 right now. So this is a great time to see it. After the sun and moon and maybe Jupiter, more detail can be seen on Mars than any other solar system object. And there's a lot here to see, and we'll talk about that more in a minute. But there's a few things that we should know before we do that. Mars has an axial tilt of almost 25.2 degrees. Ours is what, 23.5 on the Earth, gives us our 4 seasons. Mars is tilted slightly more. And right now it's early summer in the southern hemisphere. So it's kind of like early January for us. And so when we look at Mars, we're really just, mostly what we see is southern hemisphere. The northern hemisphere right now is tilted partially away from us. So no matter what, we can't see the furthest latitudes north on Mars right now. But the southern pole and the southern regions are right there for us. Mars's day is 24.6 hours long. So it's about 37 minutes longer than it is here on Earth. And what does that mean? That means if you were to come out and view Mars at the same time every night for the next couple months, you will see Mars shifting slightly eastward by about 9 or 9.1 degrees of longitude. So it's really interesting. If you come out a week or so later, you'll see roughly a sixth of the rotation in Mars at the same time of night each week, basically. So it's kind of an interesting thing to do. And for imagers, it's also an interesting thing to try to pick up that detail. For visual people, it's really dramatic to see the rotation changes and how the different surface features rotate into view. So what can I see on Mars? So this is a map taken from Mars's orbit by one of the NASA orbiters and printed in Sky and Telescope. This basically shows the more famous or largest features on Mars and the ones that visual observers like to try to look at when they're looking at Mars. The largest features that have the biggest changes in contrast and brightness are called albedo features. And these are the ones that stand out the most on Mars. And the one that stands out the most by far to me is Syrtis Major. To me, it kind of looks like a Y-shaped feature. This is upside down, but this would be the Y, and then here would be the stem. Some other features on Mars that you can see potentially are some of its huge mountains, its giant craters, its vast deserts, and also its high plains. Mars has some deep canyons as well that we'll talk about in a second. And some of these features may have formed through the flowing of water in Mars' ancient past. Indeed, the polar caps, the southern polar cap is still filled with dry ice. So it's kind of interesting. Also, one thing to note, one thing can somebody mute themselves, whoever was coughing? One thing that's interesting to note, and it's something I've picked up on in the last couple of months of looking at Mars, as Mars goes through its seasons, these features can change. They change in size, in color, in shape, and also in brightness. And there's been some features that I haven't been able to see on my map, but I see through the eyepiece. And then I realized, oh, it expanded because it's coming. Summer is coming into the southern hemisphere. The polar cap shrinking is an obvious example of that. I've seen over the last 2 months the polar cap shrink by maybe a quarter. So these are kind of the things that you can look for as a visual observer. So the two hemispheres of Mars. These are a couple of images that I've taken in the last few weeks through my Maxutov telescope. And so the one on the right is centered on 95 degrees longitude, and the one on the right is centered on 266 degree longitude. So almost exactly 180 degrees apart, more or less. So some of the features that you can try to look for on Mars, let's start with the image on the right. You've got Terra Cinerum, which is this feature. See, it's a little bit darker here. There's a series of troughs called Claritas Fossae, which is in this region. Probably one of the more famous features on Mars is this Eye of Mars feature. And if we were in person, I'd ask, show of hands of how many have heard of that. This is called Solis Lacus, and this feature is famous. It goes back centuries. Back in the mid-19th century, when astronomers thought that there were canals on Mars and people on Mars, they thought that Solis Lacus could have been the capital city because they had seen all these like little tendrils and tentacles coming through it, and they thought those were canals feeding water into this giant city on Mars. So one thing to look for if it's out is Solis Lacus for sure. It stands out pretty nicely. In the northern hemisphere of Mars, in this area, you've got the deserts. So you've got Tarsus, Arcadia, Cenorius, I think I pronounced that right. Tempe is up here, as well as the Sante Desert down here. So these stand out pretty well from the darker features on Mars as something you can look for, but these are just vast deserts. Some of them are crater strewn. There's several large mountains and ancient volcanoes on Mars. This image doesn't show it too well, but there's a chain of 3 large mountains, 1, 2, and 3. I hope you guys can see that. It shows it up better on my regular image. But these are the volcanoes Pavonis, Arcia, which is the easiest one to see. You can even see a little peak right here, potentially. And Cenorius is a little bit faded, but it's right here. If you guys can see this little brightening up here, this is Olympus Mons, the tallest volcano in the solar system, at about 85,000 feet high. It is approximately 400 miles long, too. So 400 miles long and 85,000 feet high, so it's about 3 times taller than Everest. Valles Marineris is this dark feature here coming off the western limb of Mars. This was named for the Mariner 9 NASA mission in 1971, and it was the first probe from Earth to reach Mars orbit. So they named this feature over here Valles Marineris because they kept an eye on this area. So 180 degrees separate is, again, longitude 266 in this image. And here's the famous Syrtis Major, the Y feature. Can you see the Y right here? So when it's out, this is the first feature I look for. So it's generally has the strongest albedo for me, a contrast with the surrounding area. It's actually thought to have been a shield volcano, just a gigantic shield volcano, and all this was lava that flowed out of it. It borders some of the southern lowlands down here and some of the northern highlands up here. And they think that the darkness that you see on Syrtis Major comes from the volcanic basaltic rock flowing on the surface. Just below Syrtis Major is the Hellas Basin, another one of the famous features and something that really stands out through an eyepiece. This is a huge impact crater about 7,152 feet deep and about 1,400 miles long. So think about that. So this feature is approximately, I think, the distance basically from here to Los Angeles, or here to, you know, Las Vegas at least, is the size of this round feature here. And it's a lot brighter than Syrtis Major, which makes it really stand out. Mare Terranium, which I recall is this region down here, is an ancient cratered plain. And then Hesperia, which is, as I recall, right about here, is the broad southern lava plain. So this must have been a volcanic region again back in the day, a few billion years ago, and that lava created this flat plain. And then Terra Samarium is the southern heavily cratered region. It's also a highland, so it's got some elevation to it. So these are kind of the main features that you can see when you're observing Mars, and something that I look for when I look for it. So through the eyepiece, some observing tips. And as somebody that works with the beginner program, it really stands out to me, some things that people do when they look through the eyepiece at planets. People can be really impatient on the planets. And for Mars particularly, you need to be really patient. Some observing tips. Wait till Mars is above the southern horizon, because that's when it's near its highest point in our sky. So remember I mentioned earlier that you look through less atmosphere when something is higher in our sky. When it's at the southern horizon, it's at the highest point. So therefore, you're looking through the least amount of air, which tends to give you a very steady, or more steady, and more transparent and stable image. Let your telescopes cool down for more than an hour before observing Mars. A lot of times people will run their scope out, take a look at Mars or another planet and say, I don't really see anything, it's not very steady, give up and go inside. Your telescope needs time to cool down, especially this time of year as we're getting into the cooler season. You gotta let your telescope cool down for at least an hour. I use a Maxitov telescope, and for that telescope, I need 2 to 3 hours beforehand before I start to look through it. Otherwise, you'll have a wavy image, and it's really hard to make out any detail. So again, do not spend 30 seconds looking at Mars and give up. You need to train your eye to seek out your subtle features and contrast, the stuff that I talked about a minute ago. And this will take time. Spend 30 minutes or more getting used to these features. What will happen is there'll be moments of atmospheric clarity. And during those moments, things will just pop out at you. The polar cap will always pop up because it's a very bright white object on Mars. But the rest of the objects really require some atmospheric stability and a trained eye. So the more times you go out and look at Mars, the better you'll be at seeing the detail. Don't expect to go out once or twice and being able to see this detail. You need to go out many more times, and over days and weeks, you'll pick up a lot more stuff. And as I say, the more times you observe it, the better. Choose your equipment carefully, as Mars can be really temperamental. Refractors can give you the most contrast and sharpest views, since they don't have a central obstruction. However, refractors are also the most expensive kind of telescope. And so the bigger refractors are obviously very expensive. So it's kind of a trade-off between a really sharp, crisp image and less resolution when you use a refractor. Maxitov Cassegrains can give you a nice balance between having a larger aperture as well as a sharper image. Really good Maxitovs can compete with refractors with respect to clarity. But Maxitovs are famous for needing additional cool down time. So if I'm going to look at Mars at midnight, I usually have my Maxitov out at 9 o'clock so it can cool down. Large reflectors can provide higher resolution, but because they have a secondary obstruction, sometimes they have a lower contrast. Some telescopes, some reflectors can get around this by having a longer focal length and a smaller secondary, say f8, if people know what f ratio is, or longer, can create a really good planetary reflector. And that's a nice compromise between having the sharpness of a refractor and having some aperture that gives you some nice resolution. Schmidt Cassegrains are also really good for planets. They have really good resolution, but because they have huge secondaries, they can provide lower clarity and sharpness sometimes. So they're not always the best planet telescopes. And having a mount that tracks the Earth's rotation helps quite a bit with observing the planets. I cannot tell you how important this is. If you have a mount that's tracked on Mars, it gives you more of an opportunity to just stare at the planet it gives you more opportunity to catch those moments of clarity and get you a really nice image. Choose an eyepiece that provides a high contrast, a black background, high edge sharpness, as well as good color balance. I actually prefer orthoscopics for my planet observing. They're actually not very expensive, and they give you a lot of what I just described in the previous point. There are, of course, other eyepieces that are more expensive. A lot of the TeleVue or Nikon or Explorer Scientific eyepieces also make for great planet eyepieces, but for the dollars spent, orthoscopics are really hard to beat. So filters, I don't usually use filters so much on the planets. Maybe I should. These comments actually I took from Bob King's article in Sky and Telescope from the October issue, for those that have these filters. Orange will help make the dark surface features stand out on Mars. And so that's a very popular one. Violet will bring out any clouds that are on the Martian surface. And blue does a little bit as well. And if there are any dust storms on Mars, and let's hope there's not over the next few weeks, because they block out everything, yellow can be used to bring out some of that dust storm activity. So some tools and resources as you're preparing for this the next month of Mars here. Sky and Telescope has a wonderful Mars profile Java tool. There's a picture of it here on the right of what it shows, and you just pop in the date and it gives you what's on Mars at that time, plus some of the technical information like how big is Mars, what longitude are you on, etc. The October Sky and Telescope has a really nice article by Bob King. It's called A Great Year for Mars. It's on page 48 to 50. Astronomy Magazine, Michael Bakich also has a really nice article, See Mars at its Best, page 44. If you want an app to see Mars close up and get some of the surface detail information on your phone, I used Sky Safari. It comes for both Android and Apple. Some people will use Mobile Observatory, some people use Stellarium, and I believe there's some other apps for Apple as well I'm not as familiar with. But apps can be really helpful as well at the eyepiece when you just point at Mars and then you zoom in all the way, and then you tap a feature and it'll give you the name and the information on what it is. Also, if you want a nice map for Mars, I just recently purchased this Orion Mars map, an observing guide on Amazon for $12.99, and I can highly recommend that. It gives you not only the features, but it also gives you a description of what they are. And finally, for those that do not know, the Astronomical League actually has a Mars observing program, and you can get a certificate for this. And I give you the link there. It's on the astronomicalleague.org page, and just look for Mars observing program. Any questions?
Yes, I have one recommendation.
Okay.
And on the Sky and Telescope website, there is an interactive Mars Observer app, I guess you'd have to say it is, that you can enter your time and it'll automatically show you the central meridian of Mars at the time that you're looking.
Yeah,
so,
isn't that is this the same thing that this is?
Well, I was just going to say Sky Safari Pro has the same feature.
It does, but I actually use both Sky Safari and the Sky and Telescope tool, and their descriptions are different. I can tell you that, and the named features are very different.
Okay.
So I actually use both. So what you're talking about is actually this Mars Profile Java tool here.
Mars Profile
as well as Sky Safari.
Yeah.
Any other questions? Comments?
This might be a question for Donald, actually, related to filters, because I had seen a filter online about, it was a Mars filter, and I think it had two different band passes, one in the reddish and one in the greenish or something like that. Have you heard of those?
Dual color.
Would you like me to talk about these filters when I'm talking about filters, or just pass on it?
It was a single filter. I think it was, it just had two different color passes.
Yeah, Orion sells it. It's called a Mars filter. I actually own it, and it does help bring out the darker detail. It's kind of like using like Suresh said, that orange filter. Kind of does. It's kind of a reddish filter.
I know that Botter also has a planet filter that's highly rated, and I think it does kind of a similar thing from Mars.
Yeah, I think it's all sold out right now.
Yeah.
I don't think you can get one.
A lot of things are sold out right now for telescope stuff. Any other questions?
Well, thanks.
All right. Dave, I'll turn it back over to you. Get out and see Mars, everybody.
Sounds good. Thanks a lot. All right. And I'm going to present now. Okay. All right. Let me go ahead and move on here. Okay. Can you see my screen for the public service announcements? And we'll start with the first one. On the CGO imaging rig update, are either Mark or Neverman on? Doug Neverman? Okay, well, I can kind of bring this up. So,
Yes,
oh, you
I'm
are
here.
okay. So I kind of put what I thought was the status, but if you want to talk about the CGO imaging rig, that'd be great.
Yeah, we have done some training on the Takahashi. We'll probably do some more training in October. And the plane wave, things have, all the parts have arrived, and we have attached all of that, and we've actually taken some pictures on it. I took pictures of the Iris Nebula through it. That's posted in the forums, so you can take a look at that. And that happened to be 5-minute images, unguided, and it turned out pretty good. The eccentricity was pretty low. Oh, stay awake, Dave.
Sorry. Yeah. So.
And we're working on the procedures for the plane wave right now and a few other things.
Okay. When do you, so when do you think training will start on that?
On the plane wave?
Yeah. Yeah.
I'm not sure. Maybe at the end of this month.
Okay.
It's a lot of work that people get burned out pretty fast.
Sure.
Driving down there and getting that all
That's
going.
Fine. So how about we just say like sometime in November? We'll probably have a training class. Okay. Sounds good. All right. Call for Gemini articles as usual. We always like to have articles for the Gemini, some experience you've had, equipment, successes, challenges, any tips or ideas, anything at all. Send them into Father Brown. I know that he likes to collect those, so he has some for the next issue. Some articles get pushed out, but he's pretty good about getting those articles in there. I would say that especially after the Mars opposition, if you want to send in articles and especially images that you've taken of Mars, I think he'll love to put those into the next issue as well. Okay. So I had a person contact me who's a relative of a member, and they have this website called astronomyarray.com. And I looked at it. It's not a huge website, kind of a small one, but it's got some astronomy-related apparel on there. It does have some he posts each month historical dates for that month, and then a blog with some interesting articles. They're not your normal articles about space-related items. So I encourage you to go and just kind of take a look at it. It's like I said, it's a small website right now. I think he's planning on growing it and even having a podcast at some point in the future as well. Long Lake Conservation Center. Ken, you want to give us an update on that and what's going on with that?
Sure. So since COVID started back in March, the Long Lake Conservation Center has been closed for outside events, and they've had their trails and stuff open. Well, now it's come to the point where the lack of revenue, they're going into kind of a dormant mode until next fall. And so there really isn't kind of any employees left there except for one maintenance person. And Rich, the land commissioner for Aiken County, is now kind of taken the role of being in charge of Long Lake Conservation Center. And so the county board has given them until the end of 2021 to kind of run in this deficit. And we are still good to go for our star parties for the rest of this year. Our scheduled star parties during the new moon, and we can have up to 5 rooms to stay in, and the policy is 1 person per room. So it's kind of sign up online on our boards to take a spot in one of those rooms. If you have like a spouse or a family member, you can have more people in your room. If you stay off site, you can also still observe on the field, but they really only want 5 rooms being used is what they'll give access to. They still want to try and have outside people come and use the camp if possible. So they're kind of encouraging us to think about doing like a springtime star party up there, as well as our normal fall star party, kind of to help them get some revenue and stuff. So we'll be talking to them here in the future about maybe some possible dates and what the costs of that would be, to do something like that, to maybe have a early, April, May, or star party or something, maybe June, for a week long. Let's see what else. We will be having some discussions with Rich. He hasn't seen our agreement, so he wants to be able to see our agreement, and I think he wants to try and maybe redo some of the terms in the agreement because of the position that they're in and the costs that that they have to incur to have the maintenance man around. So we'll be talking to them about that. Their plan is hoping that the schools will start up in September of next year again, because all the revenue basically comes mainly from the schools and sending kids up to camp. And so if that doesn't happen next fall, I'm not sure what's going to happen after that. We'll have to wait until then. But so far, it sounds like we're secure, at least through next year. And I guess we'll have to see what happens with COVID next year.
Hey, Ken, this is Suresh. Another thing that they can consider is the people in our club that are in the school telescope program might want to mention LLC when they deal with the schools, in case the schools don't know about LLC, to try to generate some of the business for them. The schools and the libraries and the like, if they advertise to them, they might be able to funnel a little bit more business up to Long Lake.
Yeah, so when they start up in the fall, hopefully they can have enough schools to start getting some revenue right away.
So a question that I have is, I know that we have in our agreement, I think we pay $600 per year for the use of the facility for our new moon star parties that we have, and that amount is reduced by $100 every time we have a public event that we're hosting up there. We haven't had too many public here, so are we expecting to get some sort of invoice from them for the use of the facilities?
Yeah, I mean, usually Wendy and them bill us for that. Now, since none of them are employed, I'll probably have to let Rich know about that. When I provide him the agreement, the past one, he'll probably be able to notice that. But yeah, we didn't do any outreach this year really because there really wasn't anything. So it'll be $600 probably this year.
That's fine. I've got no problem with that. But of course they'll have to invoice us for that so that we can have some sort of record.
Yep. Yeah, they usually do. So we'll have to see if he has the capabilities of doing that still without the staff around.
Okay. Any questions for Ken? All right. All right, moving to our next. I think that's the last PSA we have. So any other PSA, public service announcements? Okay. It was brought to my attention that the Boundary Waters Canoe area it has been designated as an international dark sky sanctuary now. So this is the IDA has certified the BWCA as a dark sky place, and you can see on the slide their criteria for that. And this is pretty incredible because it's only the 13th designated site in the world for this. So, and in order to maintain it, they have to maintain strict program requirements for that designation. Since 80% of Americans can't see the Milky Way where they live, this is pretty cool that they are able to do this for the Boundary Waters. I confess I have never been up in the Boundary Waters, and those of you who have can probably attest to the fact that the skies are just fantastic up there. So, all right. So it is that time of year for the board member nominations. We do have elections coming up in December for 3 of the board positions, the president, the secretary, and the board member at large. We will be taking nominations beginning it with the November meeting. So it gives you a month to think about running for one of these positions. I'd like to give back to the society. We have a very large and robust society of about 520 members with all of our sites, and we provide our members with some really great facilities and great equipment. And so it is the up to the board and of course the site coordinators as well, but to make sure that our club runs smoothly. You can nominate yourself or someone else with their permission and indicate what board position you're running for or the nominee is running for. Contact Conrad Sanders, who's the board member 2 address, or you can just send something directly to him. I believe those are all on the website with your nomination, or you can send it to the Mass Board email site, and we'll make sure that Conrad gets that. Nominees will be announced at the November meeting, and nominations will close as of the close of the November meeting, and then the nominees will be asked for a photo and a brief narrative bio on why they are running for the position to be published in the forum and in the Gemini, the December Gemini. Any questions about that? Okay. Astronomical League. Jerry Jones, are you on? I thought he was going to be on. As he searches frantically for his unmute button.
He's probably out enjoying his new observatory.
Oh, I see. Yeah, maybe. Because I thought he had a couple of awards for tonight. So, all right. Well.
Hey, Dave. Yeah. While we're waiting for Jerry, it looks like Tor just posted a short video of the BWCA from he made.
Oh yeah, look at that.
Dave? What's the email for Conrad?
It's usually C-Sanders, I believe, at I think it's Gmail. Conrad, are you on?
I'll get in just a second, Dave. I'm looking for it.
Yeah, if not, I think it's also board member 2 at
MNastro.
MNastro.
C-Sanders at Comcast.net.
Comcast.net. Okay. Oh, that hurts.
Anybody hear me?
Oh, you're really squeaky, Jerry. Okay.
Can you hear me now? Oh man, I have
Yeah, a lot of feedback there, Jerry.
I have no idea why.
How's
that? Okay, hold on a second.
Put off your speaker, Jerry.
Yeah. If you're talking over a phone,
How's
and
that? Can you guys hear me?
that's better.
Can you hear me?
Yes, I can hear you. Can you hear us?
Okay. All right. Now are we okay? Can you hear me all right?
Yeah, I can hear you now.
Okay. That's pretty weird. Yeah, for some strange reason my microphone didn't work. I had to log out and log back on. But I turned my volume down, so if someone can't hear me, somebody give me a thumbs down. But I'm okay. Everybody can hear me all right for now, for the moment?
Yep, for now.
Awesome. Thank you very much. Okay. We got a fairly busy activity here. You guys have been knocking out the observing projects out of the park, which makes sense. Many of you have nothing else to do, I suppose, which is wonderful. I've got two that I would like to share with you. Don Gazdick has done both the Lunar One and the Double Star, which is very cool. Well done. I'm wondering if he's on and if he would like to talk a little bit about either one of these, either the Lunar One or the Double Star.
I am on. I guess I've been working on the Lunar One for 20 years. I didn't use any of my old observations from 98 and 99, but I've been slowly plinking away at things. Yeah, it's a lot of fun. I go back and forth on the moon. Sometimes I think it's really great, and sometimes it's like, oh, just get out of the way and let me look at other things that are more interesting. And then Double Stars, I've always liked it, so that they're both really great programs.
Thanks, and well done. That's really great. Some month, I'm hoping to make a presentation for the next step of the Double Stars, which is the Multiple Star System Award, which is really very, very cool. So hopefully, Dave, you'll be able to fit me in sometime in the next couple of months to be able to share that.
Yeah, I think we're looking at December for that, Jerry.
That sounds fine. The Double Stars, the Multiple Stars will still be there no matter what opportunity we have. So I have two other ones. One I hinted at last month, and the one that I didn't know about then was Anton Gregory has completed his Carbon Star, which is very cool. But as important, perhaps even more important than that, is that he has been awarded his Binocular Master Observer certification, which is positively fabulous. I think he might be the very first one. Anton, are you on? Can you talk a little bit about either one of those?
Sure, I'm here. Yeah, we'll talk about the Carbon Star first. I think that there are 100 carbon stars to observe, and since most of them are variable stars, I was able to use the American Association of Variable Star Observers plotters to generate finder charts for, I think, all but two of them. They also, of course, on those plots have reference stars for your comparison stars. So even though it wasn't part of the program, those that I was able to make a good visual observation of their magnitude and make an estimate, I went ahead and reported those back to the variable star people. The program also required just that you sketch a little star field with it. Now, the one thing I didn't realize at first, but then after I was observing them for a bit, I realized that the carbon stars, they often really stand out because they're orange or amberish. But also, I think because of their color, they don't really twinkle. So because the atmosphere scatters blue light, and well, they're not blue. So they're much steadier than the other stars. And so once you see it, it's like, oh yeah, that's it. That's the one. That's the little red dot. Well, anyway, it was a good program.
And that has been my experience as well regarding the how well the carbon stars stand out, and for that reason, it's actually one of the programs that is, once you find them, then you found them. It's pretty cool that is a reality and a truth. What else have you got? What can you tell us about your master position, your binocular master observer?
Okay, well, just to set the record straight, I've sent my application in. It was acknowledged, but I haven't received the official certificate yet. Okay, but Yeah, I think all the pieces are there. But in any case, no, I really enjoy using my binoculars because you can just grab them anytime and go outside. And I'm sure that, well, we all understand this already, but all these observing programs, they're generally you're expected to use a telescope, but you don't have to. You can use whatever instrument will show you the target. And so a lot of the, well, even the Carbon Star, I did with binoculars. Working on stellar evolution, I've done a lot of that with binoculars because it's just easy and the targets are bright enough. And it's something that I can just do here at home whenever the skies are good. So anyway, I think binoculars are great instruments. I mean, they're the ultimate grab and go instrument for observing.
Well done. Well done. Congratulations on that. That's fantastic. And the rest of you, keep them coming. It's so wonderful to see all of your logs come in and just lots of fun to review them and see what's going on. I know that Kevin Carr has got another one that I hope to make an announcement sometime next month. And so keep them going. And as the slide is there, keep getting out there and observing.
All right, Jerry, thanks a lot. Appreciate that. Okay, let me see what we've got next here. Okay, so next month, we're going to be meeting on Thursday, November the 5th. This will be an online meeting. Don't forget, the board member nominations will be due then, so seriously consider running for one of the board positions. And, of course, as always, see the MAS main page for details about the meeting. Okay, anything else before we move to our featured speaker? All right. Well, I'm pleased tonight to introduce a man who has been interested in astronomy for a very long time. He states that he's got his first scope at age 12. It was a 4 1/4 inch back in 1963. It's been a few years. His college background is heavy in math, science, math, physics, and chemistry. He has degrees in anthropology and philosophy, but it was really when he moved to California in 1977 from Indiana, my home state, and found some dark altitude sites that he got into astronomy. And now he's 31 telescopes later, and he's got 345 different eyepieces down the road since then. He worked for Scope City from 2005 to 2012 when it closed. And at that time, he opened up his own business, eyepieces.etc.com. Well, please join me in welcoming Don Pensack, owner, operator of Eyepieces, etc., and he's going to talk about nebula filters tonight. Go take it away, Don.
Okay, thanks. I appreciate the invitation. I think I should probably start with a few basic things and then slide into just exactly why nebula filters work. A few years back, I decided to actually compare them all. So I bought 52 different filters and spent a lot of time under the stars basically comparing this filter and that filter to see just exactly what they do, and then trying to correspond what I saw with the astrophysics of what I was looking at. So basically, we have to figure out what is actually happening in a nebula. When we talk about a nebula filter, what exactly is happening in the nebula that causes it to emit light? And it's because nebulas are made of primarily hydrogen and helium, but mostly hydrogen. And though cold hydrogen does emit some energy, and it is capable of being picked up, it's mostly when a nearby star puts out a lot of energy that's absorbed by the hydrogen gas and then re-emitted by the hydrogen gas. What actually is happening on the molecular level is that the electrons are being shoved into higher orbitals around the nuclei, and then they fall back down into lower orbitals and emit energy. And in any hydrogen nebula, the energy that's emitted is mostly in a wavelength we refer to as hydrogen alpha. Anybody who has done any photography knows what that is. It's in the deep red. But oxygen is also excited by the presence of nearby stars, and actually it's typically hotter stars that excite the oxygen molecules. And helium is also a glow factor in most of the nebulas. So that's actually what's happening in the nebula. So when we see the light of a nebula, we're not seeing the light of a star. We're seeing light at just a few discrete wavelengths in the spectrum. And that's where all of the energy comes from. And it's knowing that we can actually apply a scientific approach to try to make the nebulae stand out from the background. But the first thing that is not intuitive, but the first thing you have to understand is that when you look at a nebula in a telescope, it's not just the brightness of the nebula you're looking at. It's the brightness of the nebula plus the brightness of the night sky. If we could somehow rather magically transport ourselves to outer space, nebulae would actually be dimmer than they are when we look at them, because we have the light of the night sky superimposed on the nebula. Now, how does that work? Well, let's say for our sake argument that the nebula is 4 times brighter than the night sky. Now, if it's 4 times brighter than the night sky, you have a contrast ratio of nebula to sky of 4 to 1. If we add some light from the sky to it, let's say we add 1. We're going to add 1 to the nebula. We're going to add 1 to the sky. Now we have a ratio of 5 to 2. That's not as big a ratio as 4 to 1. So the nebula has become harder to see. And when we continually add light from the sky, it becomes 6 to 3, 7 to 4, 8 to 5. And the ratio of brightness of the nebula to the brightness of the night sky diminishes. And that's one of the reasons why, as we go into more and more light pollution, nebulae become harder and harder to see. They just don't stand out from the background. So we have an issue, however, because our night vision, which we refer to as a scotopic vision, our night vision is not sensitive to red light. It's a good thing too, because otherwise our red flashlights would be really annoying. But we're not sensitive to red light, so we just don't see the hydrogen alpha wavelength. But as it turns out, every nebula that emits light in hydrogen alpha also emits light in hydrogen beta. And hydrogen beta is right smack dab in the middle of our peak sensitivity for night vision. So the hydrogen beta light is a light that is very important to us when we're looking at nebulae. And the other 2 lines that are very important to the spectrum when we're looking at nebula are the oxygen 3 lines. Now, you would think, well, what is oxygen 3? Oxygen 3 is an oxygen atom that is stripped of 2 electrons. Not 3, 2, because oxygen 1 is just a neutral atom. So when it recombines with electrons, there's free electrons, obviously, in a gas cloud. It emits light at these 2 discrete wavelengths that we can see, and those are right smack dab in the middle of our peak vision too. So let's talk about how filters work. They figured out by putting a variety of different layers of material on the glass that we can make the glass transparent to certain wavelengths and opaque to other wavelengths. So by restricting the bandwidth of what comes through the glass to only the wavelengths of the nebulae, we filter out all of the light of the sky that was glowing at all the other different wavelengths. And heaven knows these days the light of the sky glows at virtually every wavelength there is in the spectrum, thanks to the 50 bazillion kinds of night lights that we have in our cities. So by restricting the bandwidth, we let the nebula come through the glass in its full brightness, but we have darkened the background sky. And so that ratio that we may have had of 8 to 5 goes back to being 4 to 1. And so then the nebula contrast with the background sky is improved very dramatically. What actually happens here is that the nebula is dimmed by maybe 1/10 of a magnitude, where the background sky is dimmed by 3 magnitudes, or maybe 3.5 magnitudes. It depends upon the bandwidth of the filter. And so by having a filter in there, you dramatically improve contrast. And that's what our eye is most sensitive to, contrast. We see contrast. We don't see brightness, we see contrast. And so different nebulae emit light at different wavelengths. Some nebulae, like planetary nebulae, for example, have this really, really hot blue-white white dwarf in the center of the nebulae that really excites the gas. And so you get a lot of oxygen glow. It takes more energy from the star, more ultraviolet radiation to emit, to be absorbed by the nebula before oxygen glow becomes an appreciable part of the glow. All of the planetary nebulas also glow in hydrogen, but it's at a very reduced level. So an oxygen-3 filter can be a great filter for enhancing something like a planetary nebula, because we have basically oxygen-3 light being emitted by the nebula, and that's all that's passing through the filter. And those filters can get a bandwidth that is extremely narrow. I mean, we're talking maybe with oxygen-3 of 10 or 12 nanometers wide. Now our vision goes from, our night vision doesn't go as wide as our day vision does. We have about 350 nanometers of sensitivity across the spectrum for daylight vision. But our night vision really only has about 100 to 150 nanometers of peak vision. And so by restricting the bandwidth down to maybe 10 or 12 nanometers, we really improve contrast. But the big hydrogen gas clouds, things like the Orion Nebula, the Lagoon Nebula, the Swan, the Trifid Nebula, the Eagle Nebula, etc., those emit a lot of light in hydrogen light. As a matter of fact, if you take a look at the pictures of them, not too surprising that most of those appear red, because that's where the predominant energy from those nebulae is coming from the red wavelengths. We unfortunately don't see those red wavelengths, but we can see the hydrogen wavelength in the blue, and so that becomes the most important wavelength for us to see. And we have a variety of different filters. We have a filter that will pass only that hydrogen beta line, and we have a filter that will pass only the oxygen lines, and we have a filter that passes the hydrogen beta and the oxygen-3 lines. And then there are filters that are, well, you guys are probably all experienced in photography and different types of photographic filters, but they typically have wider bandwidths than the visual filters because they have the advantage of being able to take a time exposure and actually expose things over a period of time, where our eye has just, well, I think we function as about a 30th of a second in terms of our exposure. So that's basically how the filters work. Now, assuming that we can match the filter to the nebula, the question mark then becomes, well, what about magnification? Because what happens with magnification, and we all know this from our telescopes, is that as you increase the magnification, the background sky gets darker. But any extended objects like the nebula will also grow darker at exactly the same rate. So at some point, the background sky has already become about as dark as it's going to get. Putting a nebula filter on to reduce the brightness of the background sky is not going to help. You can't get any darker than black. But the nebula has become dim by virtue of the fact that you've increased the magnification so much. So all of these filters work best at very low magnifications. We usually say up to about 10 times per inch of aperture in the telescope. Maybe you can stretch that to 12 times per inch in some telescopes, especially with the brighter nebulas. But since so many of the little planetary nebulas are really best at very high magnifications, they're not really best with filters. They're best basically by just employing high magnifications to look at them. A filter isn't going to help at that high magnification. But if what you're looking for is the planetarium among a field of a whole bunch of stars, and the planetaries have a tendency to be kind of small, then using a nebula filter at low power will help identify it in the field of view. As a matter of fact, some of the hardcore nebula observers do what they call winking. They take the nebula filter and they pass it between their eye and the eyepiece and go back and forth like this, because when they put the filter in, the stars all dim because you're restricting the bandwidth, but the nebula does not. So you can basically then see which object in the field of view dims and which object doesn't dim. And that blinking or winking technique is a way of making sure that you have found the object that you're looking for. So I also would point out that if you want a more complete rundown of just exactly what kind of filters exist and what they do, I'll refer you to my own website, eyepieces.etc.com, because on the left-hand edge of my homepage, down at the bottom, there's a whole bunch of essays, a link to a whole bunch of essays, and one of those links is all about nebula filters. So I would refer you there if you want to read something that is much more in depth than what I'm talking about tonight. But the interesting thing about the filters is that there has also been a revolution in these things. They weren't common before about the late 70s. And then gradually they became more and more and more common. Today there are, at last count, over 250 different ones from different manufacturers, ranging in price from like $30 on eBay all the way up to like, well, all over $1,000 actually. So the difference between all those filters has to do with the nature of the bandwidths. And the wider the filter, the lower the contrast, but the cheaper the filter is to make. So that's one of the reasons why you see that some of the brand names that you're familiar with, Lumicon, Astronomic, Teleview, why they're so expensive. Because they have restricted the bandwidth to make the contrast as high as possible. And they could have made them cheaper by making the bandwidths wider, but that would have reduced their effectiveness. So the key here is, how do you make the filter as effective as possible? And so bandwidths for the various types, I'd say that on a nebula filter, like what we refer to as a narrowband filter, that's a filter that passes both the hydrogen beta and the oxygen light, probably something in the 22 to 28 nanometer range is going to be a really good and effective filter. For an oxygen 3 filter, which only picks up the 2 oxygen lines, it can be as narrow as 10 or 12 nanometers actually and be an effective filter. And for just the hydrogen beta line, and by the way, what is that filter used for? Well, it turns out the very, very faint hydrogen nebula only glow in the light of hydrogen. They don't have nearby stars that cause them to glow at high temperatures. And so all the light emitted is hydrogen, and they're all faint. They go by the name of sharpless this and sharpless that, and they can be things like the California Nebula. We're all familiar with that, right? Or the IC434, the nebula that's behind the Horsehead, for instance. And those nebulae emit light only in the hydrogen. So there, the hydrogen beta filter is the most useful filter because it restricts the bandwidth to the greatest degree and also produces the greatest contrast. And there you can get as low as a 9 or 10 nanometer bandwidth and still have a quite effective filter. So if you were going to start out with just one, I would suggest that you start out with what they call a narrow band, the filter that passes both the hydrogen beta light and the oxygen light, because that way you don't have to be a scientist to figure out what energy is being emitted by the nebula. You don't have to look up its spectrum to see what filter is going to be the most effective, although you could do that. That's a very scientific way of approaching it. So that filter would be probably the universal nebula filter, and that's something that I could recommend for everybody as a starting filter, and then probably work into the oxygen filter and the hydrogen beta filter later on. So that's, I don't know, that's probably it in a nutshell. I don't need to drone on and on and on about nebula filters. maybe somebody has a question for something I didn't cover or that I glossed over.
So are there any questions from anybody then?
Hey, Don, this is Brandon. I wanted to ask you, maybe if you talk to us a little bit about Steve Smith.
About what?
Sorry, another member had a microphone issue there.
Okay.
I was gonna say, would it be possible for you to tell us a little bit about the different manufacturing of filters, and maybe also speak to cleaning of filters? I think that would be
sure.
a lot of us.
Of course. Filters are very complex things. They know exactly what materials are going to be plated on the surface in order to produce the bandwidth that they're looking for. But the machines that put these coatings on a nebula filter can have 75 different layers. We're not talking about something with only 1 or 2 layers like on a mirror. We're talking about a huge number of layers of transparent material that act together like in an interference way and a constructive and destructive interference to produce the bandwidths. They're applied a whole chunk of layers at a time. Each stack of layers is known as a cavity. And the more cavities that are put on the filter, the narrower the bandwidth gets. Ultimately, you can make the bandwidth extremely narrow, but then the maximum transmission of the filter starts coming down. So there's a fine line between making the bandwidth narrow and making a high transmission. The process by which you make a filter with a high transmission and a narrow bandwidth is a process that costs money. So that's why the filters can be as expensive as they are. But the more cavities that are applied to the filter, the more effective the filter is going to be. And that's where the inexpensive filters differ from the expensive filters. They use fewer cavities of material in the process of plating. That way they can turn out more filters more cheaply, and the filter can be moderately successful in the marketplace at a very low price point. Now, as for cleaning the filters, the materials that are plated on are usually things like oxides and fluorides and fairly hard materials, but they're not immune to handling errors. You instead of thinking of it like an eyepiece, where the surface of an eyepiece is very, very hard and you can clean that surface very easily and not damage anything, I like to think of them more like the surface of a telescope mirror. You have to treat it more like that surface, very gingerly, very easily. You're not going to damage it if you take care, but you don't wipe it with a dry rag. You don't breathe on it and then clean it with your t-shirt. I mean, that's not going to help the filter. The coatings are typically on the inside where the threads of the filter are. And if you're going to clean it, I would suggest something gentle like a Q-tip and some alcohol, or maybe a Kim wipe, or something that's not going to do any damage to the surface or leave streaks behind. You don't want to leave streaks, because then you have to clean it all over again, and the more times you clean it, the more likely you are to damage it. Fortunately, filters don't get dirty that much, because you're putting them on the bottom of the eyepiece or on the bottom of some type of device where you're not breathing on it and your eyelashes aren't hitting it. But inevitably, of course, you're going to get a fingerprint on the thing. So, cleaning is something that you're eventually going to have to do. But I say alcohol on a cotton ball or alcohol on a Q-tip, just something that's gentle. You don't rub real hard and you don't go over it 1,000 times. Would be fine for cleaning. And if they don't last forever, well, we don't either. So, you're not going to will it to your grandchildren. So.
Hey Don, this is Suresh.
Yeah.
You said in your talk you mentioned reviewing 250 nebula filters, give or take.
52 actually.
52.
I have
Of those, just putting you on the spot a little bit, what are your top 3 or 5 overall nebula filters, and then your top 3 or 5 of the more economical nebula filters?
Well, I was just going to say the ones that really stood out because what I did was I not only tested them in the field, but I sent them all off to my friend Augie Golub to test. And so he ran every single one of them through the spectrophotometer and actually sent me the results. So I have the results all the way from ultraviolet to infrared for every one of the filters that I have. And the ones that really stood out, top tier, the best, you can't lose. You can throw a dart at a dartboard, and if it hit that name, you'd win. Astronomic, Teleview, and Lumicon. Those three brands. And with Lumicon, I'm talking about filters since 2018, not necessarily older filters. With Teleview, I'm also talking about since 2018. With Astronomic, I'm talking about since 2016. Filters before that were made differently. They had different philosophies on how they make them. And so it's the recent filters that really kind of stand out. There was a second tier of filters. I'd say that I could recommend them, but they seem to vary a little bit more in quality from filter to filter. And so you have maybe a little bit poorer odds of getting an absolutely fantastic filter, but they're still pretty good, and they're good, certainly good for the price. And that would be the DGM filters. That's Dan McShane, in case you want to know where the DGM came from, and the Orion nebula filters. So it'd be like the Orion Ultra Block, the Orion Sky Glow, that type of thing. Ultra Block is their narrowband filter, and DGM, their narrowband filter is known as the NPB, or narrow passband. And I did test quite a number of other brands, Explore Scientific, Star Guy, Optolong, Thousand Oaks. I could go on and on, but all of these varied so significantly in quality from filter to filter that I either that or had just the wrong bandwidth for the type of filter that they were going. I can't really recommend them. So it's most of them are inexpensive, and so if you're 12 years old and you're paying it for it with your allowance and stuff like that, I think you could be forgiven if you get a lower price filter that isn't quite as effective. But for most of us that can afford something a little bit nicer, and then let's talk about the sizes too. 1¼ inch versus 2 inch. All these filters are made with 1¼ inch size or 2 inch size. Well, if your eyepieces, if your low power eyepieces are 2 inch, then a 2 inch is the right size. But also most 1¼ inch adapters for 2 inch focusers are threaded on the bottom for 2 inch filters. And coma correctors are threaded on the bottom for 2 inch filters. And a lot of Barlows are threaded on the bottom for 2 inch filters. So a 2 inch filter can also be used with 1¼ inch eyepieces, which kind of makes it the universal filter size. It's just unfortunate that because there's 3 times the area of glass in a 2 inch filter that there is in an 1¼ filter, they're about twice as expensive as the 1¼ filters. But it's, I would advise 2 inch filters if you can get away with it, simply because if you take a look at an 1¼ filter, the glass sits in an aluminum piece, and then there's a retaining ring that threads in on top of it to hold it in place. So you don't get a full 1¼ inch aperture through the glass filter. It's going to be reduced. And with a 2 inch filter on the bottom of an adapter, and you're using your 1¼ inch eyepiece, glass occupies the entire 1¼ inch opening in the adapter. So there's absolutely no vignetting or anything on the edge caused by a retaining ring. And you're also looking only at the best part of the glass, which is right smack dab in the center. So it's that makes 2 inch the kind of the universal size, unless your telescope only takes 1¼ inch eyepieces, in which case, well, there's no choice. But so does that answer your question, Brandon?
That was Suresh that asked that question. Yeah.
Oh, yeah. Suresh. Sorry.
Thanks,
Yeah.
man. That was great. Appreciate it.
Yeah.
I do have another, but I know we have 52 other members, so I'll wait and see if somebody else asks some questions.
Okay.
I've got one.
Sure.
So when I was doing research, for a oxygen 3 filter, I was looking at some of the band passes for the
the cheaper narrowband filters, and I noticed they would often miss one of the two oxygen bands.
Yes.
So I opted to get a slightly wider filter that would pick up both. Did I make the right decision?
Well, actually, not a bad idea. What has happened with filters over the last 30 years is that they've all gotten wider. And that's because we're using telescopes with shorter F ratios. As it turns out, these nebula filters, when the light comes through at a more oblique angle, do not have the same spectrum of reflection or spectrum that passes through the filter. They're basically perfect directly on axis, and then when you move around to an angle, the filter characteristics change. So in order to not have the bandwidth of the filter shift because of the light coming in from a sharp angle to the side in a short F ratio scope, they've made the bandwidths a little bit wider to guarantee that if the light happens to come in from an angle to the side, it's still going to pick up those same necessary lines. The advantage of a wider filter is that it doesn't matter whether you use an F2 scope or an F10 scope, you're going to be able to pick up all three lines in the filter. Being able to control the quality of the filter so that you can have the narrowest bandpass, still pick up all the light from the side from a short F ratio scope, and still not miss one of the lines, yes, money. And that's why the expensive filters cost more money. Yeah. But the only disadvantage of the wider bandwidth is that you lose a little bit of contrast. And so you're not getting the maximum contrast. But like I tell people who own, I've told people on cloudy nights a lot, you know, that bought $20 filter on eBay. For instance, a nebula filter that costs $20 is still better than no nebula filter. So, you know, it's there's something to be said for that. So there's not a problem with that. But eventually, you might want to get something with a little bit narrower bandwidth.
Thanks.
Anybody else, or you want to back to Brandon?
Yes, I'll speak up. Can you hear me? This is
Yeah,
Thor.
Sure.
Yeah, the hydrogen alpha is at.
What about hydrogen alpha?
Hydrogen alpha is at 656.
Bob, full call. Could you mute, please?
I believe I am muted.
Hydrogen alpha is at 656, which is a wavelength that we are, humans are not really very sensitive to.
I know.
But we can make our cameras quite sensitive to them.
Mm-hmm. That's right.
And hydrogen beta is at
486.
Yeah, which we are much more sensitive to.
Yeah.
But you mentioned that these two are usually present simultaneously.
Yes.
But what is their relative intensities?
Hydrogen alpha is usually 3 to 4 times the level of hydrogen beta.
Radiometrically?
In terms of actual energy, in terms of flux.
Yeah. So the radiometric flux, our sensitivity is much higher.
Oh yeah, our sensitivity to hydrogen alpha compared to hydrogen beta is about 180 to 1.
Okay. So actually, we'd be, better off if we're doing visual observation to focus on that H beta line.
That's correct. That's correct. That's why the visual filter for hydrogen is a hydrogen beta and not a hydrogen alpha.
And do you make filters that do both?
Actually, there are filters that do both. Astronomic, for example, in their UHC filter, which is considered their narrowband filter, picks up the hydrogen beta line, 2 oxygen lines, and hydrogen alpha, sulfur 2, and nitrogen 2 in the deep red at the same time.
And you think that would be effective in my light polluted Minneapolis home?
Yes. As a matter of fact, that's an excellent narrowband filter because the red doesn't really matter that much for you. but it would also be usable for a camera. The only difficulty with that is that the red wavelength is a very wide bandwidth, and it goes well into the infrared. And so that may not be the best for long duration astrophotographs. Short ones, yeah, but not long ones. For that, you need a specialty hydrogen alpha filter, because what most astrophotographers do is they ignore the hydrogen beta entirely and just shoot in the hydrogen alpha and pick up only that one.
Why do they do that, do you think?
Well, the answer is because you're losing some energy to do that, but at the same time, you're narrowing the bandwidth down in the hydrogen alpha to such a narrow bandwidth, you've excluded all of the light pollution in the sky. I've got a friend here in LA who takes 2.5-hour exposures at hydrogen alpha and gets absolutely wonderful photographs.
In LA?
In LA, right smack dab in the middle of LA.
No, that's crazy.
Yeah, but you can do it because he's using a 3 nanometer bandwidth hydrogen alpha filter. So
he's not getting much energy. It must take a long time then.
Well, yes, he has narrowed it down to such a point where it takes a certain period of time to expose enough energy. But I remind you that the majority of the energy from a nebula comes from hydrogen.
Right.
So if you take a look at the relative flux in every nebula, the hydrogen alpha line is the one off the top of the chart.
Okay, thank you.
Yeah. They do, by the way, make dual band filters that pick up the hydrogen beta and the hydrogen alpha, but most astrophotographers can't figure out why.
No, tell me again the ratio of the natural radiometric ratio.
It's usually at least 3-to-1, but more often than not 4-to-1 or 5-to-1 between hydrogen alpha and hydrogen beta. You see, what's actually happening at the molecular level is hydrogen's electron sits in its lowest orbital most of the time. When it's excited, it goes up in orbital, and then it falls back down to its lowest level. That light that's emitted is hydrogen alpha. And that is the most likely event to occur in a hydrogen atom.
So that's the strongest signal.
That's the strongest signal. When it gets bumped up 2 orbitals and drops back down 1, that is a much rarer occurrence. And that's the hydrogen beta light. And that happens in all hydrogen atoms as well. It just doesn't happen to as great a degree.
Okay.
Anybody else?
Brandon, you said you had one more.
I did, yeah. So my question is, I know you're speaking on nebulas tonight. Would you mind if I throw a planetary question at you? I wondered if maybe you'd be, because like tonight our featured planet was Mars. Our members mentioned some of the filters there. Wanted to get your opinion around Mars, maybe and maybe beyond Mars, maybe just Jupiter and Saturn are also obviously a big planetary object.
Okay, I've used all the color filters. As a matter of fact, 20 years ago, I had 25 different color filters in my kit. All the different blues, all the different reds, all the different yellows, etc. And then I discovered the magenta filter, which transmitted both the red and the blue at the same time, which was great for Mars. The red side of it picked up all the dark markings on Mars. The blue side of it picked up the ice cap and the limb clouds. And it was a really good filter, except that it made Mars look pink. But you had to kind of put up with that if you wanted to use the filter for features. And then a friend of mine suggested, Don, why don't you try the Bader contrast booster? And I said, well, Daniel, that's a minus violet filter. It's designed for refractors to filter out the violet fringe on stars, the chromatic aberration. And he said, try it, trust me. So I tried it on Mars. It was like a smack in the face. The difference was like tripling the size of my telescope in terms of the details that I could see. And I finally figured out exactly how it works. That minus violet feature also takes out some of the blue, and that's where most of the light scatter in our atmosphere takes place. And once you remove a lot of the light scatter in the atmosphere, the sharpness of what's still visible really pops out, And since Mars doesn't really have a whole lot of blue in its transmission, or I should say reflectance, it doesn't change the coloration of Mars much. Mars still looks like a photograph, like we see the image color in photographs when you use the contrast booster. So I'm firmly convinced that that was the best filter. And how Botter made that filter was kind of serendipitous. I think maybe we talked about this once before. They were using various materials in glass to see what happened to the glass. It turns out when they added neodymium oxide to glass, it had certain wavelengths of transmission, but it put notches in the spectrum right at places that there was some light pollution. So they thought, whoa, we've discovered that we can make a cheap glass filter that's going to act like a light pollution filter. Well, yeah, it kind of did, but it really wasn't all that effective at that purpose. But somebody used that filter on Jupiter and thought, oh my God, look at all the details. The great red spot popped out. The bands are ochre colored. There's red storms on the planet as well as white and gray storms. And that was a filter that they refer to as the moon and sky glow filter. Sometimes you see it referred to as the neodymium filter. And that was from Botter as well. And then they decided, well, if it does such a good job of enhancing contrast, let's add a minus violet character to it so that we can put it in the small refractors, improve contrast, and get rid of the violet fringe at the same time. And that's where it stood for 20 years, because those filters came out over 20 years ago. But then somebody decided to use it on the planets and discovered that they work fantastically on the planets. There's been a recent long thread on Cloudy Nights about planetary filters, and I think a good portion of the people there are convinced that the Botter contrast booster happens to be one of the best planetary filters that's ever been developed. And I liked it better than the magenta filter on Mars because it did make Mars pink. And on Jupiter, it makes Jupiter appear warmish toned, whereas the moon and sky glow filter makes Jupiter appear kind of a coolish tone. So it depends upon whether you prefer something a little bit more toward the blue or a little bit more toward the yellow, but they both really enhance contrast on Jupiter. But on Saturn, the contrast booster was again the winner for Saturn. So I think that the contrast booster, as a matter of fact, sold out a couple of months ago, but they finally got their act together and shipped 1 billion of them to the United States, and now all the dealers have them all over again. So the filters are available just in time for Mars, I might add. But the key here is that they are available now again. So so that makes it a possibility for somebody. The only thing I might mention is that each of the colors in color filters does have a small effect on Mars, but each of them has an effect only on certain features on Mars, like a light blue feature on the clouds and the polar ice cap, or a yellow filter on the dust storms, or a red filter on the dark markings. But I think the contrast booster just did it all. It really ended up being the best filter. I got rid of all my color filters. So.
Okay. Anybody else? Yeah, I hear static, but nothing. Okay.
Okay.
All right. Yeah. So I want to plug in for you, Doug. There. If you have any more questions for him, or if you want to contact him about getting eyepieces and/or filters, that is at eyepieces, etc. It's ETC. So eyepiecesetc.com.
And my email is don@eyepieces.etc.com.
That makes it pretty easy, doesn't it? Okay.
Yeah.
All right. Thank you so much.
You're welcome.
And that brings us to the end of our meeting for tonight. Is there anything else before we wrap it up? All right. Well, thank you very much, everybody. And get out there and observe Mars this month. It's nice and big. And it's been great having you. And we'll see you out there under the skies, hopefully. Thanks a lot.
Thanks, Don.
Thank you.
Thanks, everyone.
Okay. Clear skies, guys.
You bet.